October 29th, 2025, 7:47 a.m. Eastern Time, the moment astronomers have been waiting for, fearing, and preparing to analyze for over a year. The interstellar object known as 3I Atlas has just reached perihelion, the closest point in its trajectory to our star. A moment calculated by JPL horizons with minute-level precision. A moment that will never happen again. And we can't see any of it. At the exact second, Atlas is being blasted by nearly 770 watts of solar energy per square meter, enough heat to tear apart a fragile comet core. It vanishes behind the sun, hidden from every telescope on Earth. A perfect astronomical eclipse at the worst possible time. Harvard astrophysicist Avi Loeb revealed this uncomfortable truth on his research page earlier today. He called it a scientific cliffhanger, a moment loaded with physics, chemistry, danger, and complete observational blindness. If Atlas is natural, this is when it should fracture. A 5-kilometer body held together by weak cohesive forces shouldn't survive this kind of thermal punishment. Right now, fragments could be erupting outward in a violent cascade, a cosmic fireworks show we are fundamentally unable to witness. Or something else could be happening. Something deliberate. Something controlled. The geometry is brutal. With Earth positioned exactly where it is in its orbit, our line of sight runs straight into the sun's glare. Move our planet 6 months forward or 6 months back, and we would have had a perfect viewing angle, clear, uninterrupted, ideal for radar mapping. Instead, we're blind. Not metaphorically. Literally blind. This is the most critical moment in Atlas's entire journey, and it's unfolding in total darkness. If Earth had been just 6 months ahead in its orbit or 6 months behind, this would have been the greatest radar opportunity in the history of astronomy. A perfect alignment. A once-in-a-civilization moment. Instead, we're on the wrong side of the sun, watching the biggest mystery of the decade unfold from behind a blinding wall of light. Avi Loeb calculated the scenario with painful clarity. Had Earth been in the opposite orbital position, 3I Atlas would have swept past at a distance of only 54 million kilometers. Close enough for our planetary radar systems to lock onto it with ease. Close enough to map its surface. Close enough to build a full 3-dimensional reconstruction of its shape as it rotated through 16.2 hours. Imagine what that would have meant. Direct size measurements, rotation curves, surface topology, material density. Every detail we currently guess, infer, or debate, available as hard data. But reality offers no do-overs. When Atlas makes its closest approach on December 19th, 269 million kilometers away, the distance will be too great for any radar system on Earth. Even the most powerful transmitters would see nothing but silence. This is the cruelty of orbital mechanics. The universe gives us a visitor from another star and positions us in the one place where we cannot observe its most important moment. So now, instead of direct imaging, scientists around the world are switching to Plan B listening. Radio telescopes, wideband receivers, thermal detectors. Every instrument designed to catch the slightest hint of unnatural activity during the blackout. Because if Atlas is more than just a comet, this is exactly when it might reveal itself. When the universe takes away our eyes, it forces us to listen. That is exactly what's happening right now. With 3I Atlas swallowed by the sun's glare, optical astronomy goes dark, but radio astronomy lights up. Across the globe, dishes are turning, arrays are humming, and wideband receivers are sweeping through frequencies not normally touched by natural objects. Because if Atlas can't be seen, it might still be heard. Radio observatories from New Mexico to Australia have begun continuous monitoring, searching for anything that doesn't fit the background noise of the cosmos. A narrowband signal, a repeating pulse, a strange modulation, a temperature spike. Even the smallest anomaly could rewrite everything. Government involvement has escalated too. Congresswoman Anna Paulina Luna pushed for the release of high-resolution images captured on October 2nd images that have been locked away for weeks. Scientists are desperate for them. Geometric clues, symmetry, odd reflections, anything that hints at structure instead of randomness. But the images remain sealed, trickling out slower than the mystery grows. Meanwhile, monitoring teams have compiled a checklist of what to watch for during the blackout. Deliberate maneuvers, mini probe deployments, thermal signatures inconsistent with solar heating, artificial lights, radio bursts with mathematical structure. Any sign, even the faintest flicker, that Atlas isn't just drifting, but operating. The tension is different now. It's quieter, heavier, like waiting outside a locked door, knowing something massive is happening on the other side. Every hour, new data scrolls across consoles in silent control rooms. Every spike is examined, every dip investigated, because once Atlas reemerges, those brief, hidden minutes could reveal the truth if anything happened at all. Right now, Earth isn't observing a comet. It's eavesdropping on a mystery. Every natural object in the universe bends to statistics except 3i Atlas. It has not one anomaly, not two, but 8 separate impossibilities stacked on top of each other like a cosmic dare. First is its trajectory. Instead of arriving from a random direction, Atlas approaches within 5 degrees of the ecliptic, the thin, flat plane where our planets orbit. The probability of that happening by chance? About 0.2%. It's the kind of alignment you'd expect from a spacecraft following local traffic rules, not an interstellar wanderer. Second, the anti-tail. During July and August, Atlas fired a jet toward the Sunday. Comets never do that. Solar radiation pushes tails away always. Atlas did the opposite, as if some internal system briefly activated, defying every textbook on cometary physics. Third, its size-to-speed ratio is absurd. Bigger objects move slower. That's the rule. Yet Atlas is both enormous and unusually fast, a combination with a probability below 0.1%. Fourth, the timing. Its approach brings it close to Mars, Venus, and Jupiter in a sequence so precise it borders on choreography while staying invisible to Earth at perihelion. The odds? 0.005%. Fifth, the composition. A plume rich in nickel but poor in iron, a signature more like industrial alloys than cosmic rubble. Sixth, the dryness. Only 4% water by mass. Comets are 80 to 90% ice. Atlas is practically dehydrated. Seventh, extreme negative polarization, a behavior no comet, natural or interstellar, has ever shown. It reflects light like a surface we've never studied before. Eighth, its origin direction. It entered our solar system from the same region as the famous WOW signal within 9 degrees of the historic radio burst. A coincidence with a probability under 1%. Each anomaly alone is strange. Together, they're statistically impossible, less than 1 chance in 10 quadrillion. Something about Atlas refuses to act natural, and perihelion is where those impossibilities may either collapse or multiply. When you multiply the odds behind Atlas's behavior, the math stops being improbable, it becomes impossible. Avi Loeb ran the numbers publicly. Take each anomaly, each razor-thin probability, each statistical outlier, stack them together, and the final result is less than 1 in 10 quadrillion. That number isn't just small. It's a mathematical extinction event for coincidence. Natural explanations don't survive probabilities like that. Random chance doesn't stack 8 impossible behaviors into one object. Nature doesn't choreograph perfect planetary timing, reverse comet physics, mimic industrial alloys, and arrive from the same patch of sky as the WOW signal, all at once. At some point, the universe forces a question we don't want to ask. If something behaves as if engineered, how long do we keep insisting it isn't? Loeb's classification on the LOEB scale, a 4 out of 10 may sound modest, but on his system, 0 means definitively natural, 10 means definitively technological. A 4 isn't a shrug, it's a warning. It's the line where probability ends and intention begins. And that's why this perihelion blackout is so unsettling. Not because we lack data, but because the data we do have already points toward design. All we're missing now is confirmation. A maneuver, a signal, a heat spike, a fragment that moves with purpose instead of chaos. Scientists are divided. Some cling to exotic physics, unknown ices, rare surface chemistry, extreme porosity. Others whisper about probes, guidance systems, dormant machines drifting for millennia. But everyone agrees on one thing: the numbers are no longer neutral. They lean in a direction that terrifies and fascinates at the same time. If Atlas behaves intentionally at perihelion, the math won't just break, it will point. And the destination of that pointing may redefine every assumption we've made about our place in the universe. The blackout is ending, and now in these next hours, the most important data of the entire Atlas saga will emerge. not from what we saw, but from what happened while we couldn't. Astronomers are already lined up across continents, waiting for the first post-perihelion coordinates to arrive. Every telescope, every radio dish, every spectrometer is pointed at the dawn horizon where Atlas should reappear, a tiny spark rising beside our star. What they're looking for is simple. Did Atlas survive? Did it change course? Did something happen in the dark? If this object is natural, the intense heating it endured should have fractured it. We should see a plume of dust, a widened coma, a shattered core drifting apart like cosmic rubble. But if Atlas emerges intact, the same brightness, the same shape, the same rhythm, then something held it together when physics said it should have broken. More important than survival is motion. A tiny shift in its exit velocity, a slight deepening of its angle, even a micro change in trajectory. Any of these would signal that Atlas didn't just pass perihelion, it used it. Teams are comparing pre- and post-blackout positions down to arc seconds. One deviation could prove a maneuver. One unexplained drift could reveal intention. And then there's the fear, the possibility of silence. No fragmentation, no plume, no motion change. Just an object slipping out from behind our star as if nothing happened at all. Because that kind of silence isn't natural. It's deliberate. It's controlled. It's the silence of something that knows we're watching. Avi Loeb warned that the critical moment wouldn't be the perihelion itself, but the aftermath. What Atlas looks like when it returns to view, how it behaves, what the numbers say. Right now, we're witnessing the razor edge of discovery. Either Atlas confirms nature, or it forces us to accept a possibility humanity has avoided for centuries. The truth isn't coming someday, it's coming now, and whatever emerges from the sun's glare will change the conversation forever.